Assalamualaikum. I'm Rizwana Chaudhary Raka. Today me with my teammates going to overview a paper on cyberbullying detection from Facebook by NLP classification techniques. Basically today I'm going to cover the parts abstract and the introduction. So let's start with the abstraction part. Data-driven security is becoming increasingly important due to the complexity of cybersecurity data. To address this, a self-attention based neural network model is proposed to identify entities linked to cybersecurity. CNN is used to extract character features which are then concatenated into a word feature. The model is based on the current BILSMT CRF model and is tested on a labeled dataset. The proposed model performs better than the prior entity extraction approach. Introduction. Procedures used today to access the vulnerability of critical infrastructure mainly rely on the staff of security operations centers. Traditional manual and subjective audits, however, fall short of the necessity qualities of dynamic seals and attack surface assessment. For instance, certain frequently used tools for determining vulnerability, Servity like CVSS1 calculator, need user input and are based on qualitative assessments of vulnerability features, such as exploitability, scope, and repercussions. A wealth of cybersecurity knowledge may be found in textual sources, including vendor announcement blog, white papers, and hacker forums. Traditional threat analysis of data from textual source use the time-consuming and effective manual labor process. The security analysts are unable to properly exploit the confirmed data as a result. Thank you. So this was from my side.
Hello everyone, this is Param Govinyogi and today I'll be talking about the literature review of the above topic at first. I want to talk about a crucial issue that has plagued our society for quite a time. This is known as cyberbullying. In today's world, social media platforms like Facebook has become a breeding ground for this indigenous practice, which can cause severe emotional and mental harm to the victim. But the good news is that researchers have been working tirelessly to develop effective ways to detect cyberbullying on Facebook using NLP. One popular method is the machine learning based approach, where a machine learning model is trained on a dataset of Facebook posts that has been manually classified as cyberbullying or not. Misha et al. On 2021 developed a learning-based model that uses convolutional and recurrent neural networks to identify cyberbullying with an accuracy rate of 91%. Another model is the text analysis-based approach, where evaluation physics post context to identify patterns characteristics of cyberbullying. This approach uses sentiment analysis, keyword extraction, and language translation techniques to look for signs of cyberbullying in posts. Kumar and Yadav in 2020 found that the presence of certain types of image such as graphics or violence image and identify of the posters including that age and danger can also indicate cyberbullying. Lastly, there is a hybrid approach, which combines the benefits of both machine learning and text analysis. This approach trains a machine learning model to identify cyberbullying and then use text analysis technique to provide additional content and evaluate the post further. These models are promising for detecting cyberbullying on Facebook and can help prevent this harmful practice. However, it is essential to remember that the accuracy of these models is highly dependent on the quality and representation of the training data.
I am Allama Bokhtiyar Nafis and now I am going to present the problem statement and research objectives. In the problem statement part focuses on the challenges and proposed solutions for cybersecurity in various sectors. As we all know, the practice of manually assessing vulnerabilities can lead to inaccurate information and require complicated analysis. Additionally, the variety, lack of completeness, and duplication of security data in modern repositories contribute to these security concerns. These problems are common in both public and manufacturer vulnerability reports, making it challenging to identify and address security weaknesses through direct analysis. Furthermore, the passage highlights the challenges posed by cognitive cyber physical systems of the Internet of Things in the healthcare sector. Healthcare services and infrastructures are particularly vulnerable to major security risks, and the situation is exacerbated by the increasing interconnectedness of medical devices and services that are exposed to new cybersecurity vulnerabilities. To address these challenges, the proposed solution is to develop innovative techniques for building cognitive cybersecurity for CPS IoT enabled healthcare ecosystems using cognitive architecture and artificial intelligence to enhance automated intelligence cybersecurity decision making mechanisms with expert level ability. Detecting web attacks within URLs is also a challenging task, as different attacks can hide in various ways within their URLs, and different attacks exhibit different signatures in their URLs. Novel security models, controls, and decisions must be distributed at the edge of the cloud to support the new IoT paradigm, known as the EOT, to address these challenges. Finally, the annotated dataset may not be representative of all types of attacks and entities involved, and further research and data collection may be necessary to improve the performance of automated detection systems. In conclusion, these challenges and proposed solutions emphasize the importance of investing in innovative techniques to ensure cybersecurity in various sectors, including healthcare, IoT, and web security. In the research objectives, their proposed approach aims to enhance human cognitive capabilities in two important ways. Firstly, by addressing conflicting vulnerabilities reports and preparing trustworthy datasets through embedded security indicators. And secondly, by utilizing ensemble meta-classifier methods to enhance predictive accuracy beyond that of individual algorithms. The primary objective of this study was to determine the effectiveness of the Doc2VC based language model as a natural language filter within our proposed system. The research team proposed an architecture for an independent system that can identify content related to cyber threats from a vast amount of publicly available textual documents. By utilizing cybersecurity specific training data and custom pre-processing techniques, the Doc2VC model was trained to function as a domain-specific language filter for our autonomous system. The team then evaluated the performance of the language filter through the holdout method and optimizing the hyperparameters of the Doc2VC model. Furthermore, the proposed cognitive cybersecurity methodology and theory aim to provide a comprehensive approach to defend against dynamic and adaptive attacks to the CPS IoT enabled healthcare ecosystem. The methodology includes a cognitive architecture that models human cognitive behavior to anticipate and respond to new security and privacy threats. It also considers trade-offs and other contributing factors to get ahead of attackers' cognitive decision cycle, amount for uncertainties, and optimizes temporal feedback loops. Additionally, the methodology integrates innovative mechanisms for security privacy metrics, and dynamic security knowledge base to enhance threat prevention, detection, incident response, and mitigate of impacts. The paper also proposes a distributed system for web attack detection from URLs using deep learning techniques including CNNs and NLP models. This system can represent all kinds of URLs, distinguish anomalous requests from normal ones, and apply multiple concurrent models to enhance system stability. Moreover, the author suggests an automatic dataset augmentation method to extend the training dataset with sentences containing automatically labeled name entities to improve the performance of NER systems in challenging conditions where the annotated dataset is limited and diverse named entities may be present. Overall, the proposed methodologies, architectures, and techniques provide a comprehensive and systematic approach to defend against emerging attacks to the CPS IoT enabled healthcare ecosystem. The research conducted by this team demonstrated the potential of using deep learning techniques and models such as BERT transformers and Dog2 VEC to improve the performance of natural language processing tasks and enhance the cybersecurity capabilities of autonomous systems. I believe this research has significant implications for the field of cybersecurity and can help to protect critical infrastructures such as healthcare systems from cyber attacks. Thank you.
Hello, this is Param Gunyogi again, and now I'll be talking about how to tackle the issue that we are working on developing on Facebook cyberbullying detection system using NLP. We will compile a dataset on Facebook post comments using the Facebook API, which enables us to extract publicly accessible post comments about cyberbullying. We will filter the post comments based on specific hashtags and terms related to cyberbullying. The dataset will then undergo processing to ensure that all the data in text-based and to remove any irrelevant information. After processing, 11 attributes will be extracted from the dataset. After processing, 11 attributes will be extracted from the dataset. The text data will be converted into numerical features using NLP techniques such as bag of words, term frequency inverse, documentary frequency, and word embedding. These features will be used to train our cyberbullying detection model, which will be developed using a range of machine learning approaches, including logistic regression, decision tree, and support vector tree. Once the model is developed, we will evaluate its effectiveness. Measures such as accuracy, precision, recall, and F1 score will be used to gauge the model efficiency. We will also access the model on a separate dataset to ensure that it generalizes effectively to fresh data. In conclusion, cyberbullying is a serious issue that needs to be addressed. Facebook cyberbullying detection system using NLP approach is a step towards identifying instances of cyberbullying on Facebook and prevent harm to its user. Thank you for the attention.
Hello everyone, this is Shahriar Hossain Imam presenting the model training part. So first of all, before model training we process the data through different techniques. Firstly, I can say to where we collected the data set. So basically we collected the dataset from the different types of sources including Kaggle, GitHub, and other internet sites. Okay, why we chose the different sites? Because that due to lack of the data, basically we are working on the Facebook comments, Facebook bullying comments, so that is not available everywhere. So we collected this data from different sources and merged them, and also we collected some data from the Facebook as well. So after collecting the data, we check all how many data are there, and is there any column remain null or not. So here is the result. We can see that that this is the type. Basically the type means which types of text. So here are 1 2 3 4 5 6 7 types of data, and this is their frequency. So after combining the data, we eliminated the redundant, that means the duplicate data. Then we go through some natural language processing techniques, and later focused on the training the data. So after pre-processing, here we can see the equation and the calculation, how we calculate when you train our data set. So here is confusion matrix, the confusion matrix result. Basically we work on linear logistic regression model. Through this model we trained our data set and we get the result, and the calculation is here. True positive means situation in which we accurately forecast our favorable outcome, and the rest of the techniques you can see. So where are also the calculation of accuracy, recall, precision, and F1 score. So in this confusion matrix we can see that there are basically 7 types of data. Here is the indexing, here is the other classes, which is false prediction, basically true prediction and false prediction ratio. So from this confusion matrix we can see that the prediction is quite good. So after the confusion matrix, here is the classification report of the linear logistic regression model. So we can see that the here is the 7 classes and their result, their precision, result, recall, and F1 score, and support. So we test 4000 data and we got the accuracy of 0.7, that means 74%, which is our current model accuracy, which is quite good, but we want to be the best in the existing system. So here is the conclusion. We can conclude that we will work on our data set, and we will go through some different techniques to further modify our accuracy. We aim to accuracy near about 90%, or even more. So in our second draft and final submission, we will work on it and go through the different techniques so that we can get the maximum accuracy. So here is all from my part. Thank you.